Good morning, everyone. Hope you have slept well and we are really refreshed for this day's sessions. On the first session, we have Valentina Balan and with a presentation of Plone on Kubernetes and Rancher version 2, Helm charts and CI/CD at EEA. I'm personally looking forward to this presentation because I'm kind of Kubernetes geek, so go ahead.
So first, I'm Valentina Balan. I'm a senior DevOps engineer at the web company. I worked on the EEA project for over 8 years. And this year we did a big change. And this is the presentation that covers some of this for the EEA. So first of all, I will briefly present the terms for the people. I'm guessing if you came here at this hour, you already know everything, but I'm just going to pass really fast. So Kubernetes is a container orchestration for automating deployment, scaling, and management. Helm is a package manager for Kubernetes that is using version charts for deployment, using templating to generate Kubernetes resources. Rancher is the tool that was used by EEA. The version 1 is a Docker management platform that is based on Docker Compose architecture. Rancher v2 is Kubernetes cluster management platform, which gives role-based access control over over multiple Kubernetes clusters. And Rancher Fleet is an application, it's a tool for large-scale app deployment that was done by the Rancher team. So the requirements that we had for this year was to migrate the orchestration setup from Docker Compose to Helm. We had to preserve the structure. We had to integrate with the existing CI/CD pipelines that we had because we didn't have a lot of time for training. We had to make it as close as possible as what was before and to make it user-friendly for the release managers. Also, of course, documentation, and I will show you the questions YAML file. That is something that is for Rancher that allows you to, for every Helm chart, the possibility from the web UI to configure the application for deployment. The pressure points that we had during the migration from Docker Compose to Rancher to Kubernetes was chart, subchart template, we don't know. Services, how do they work? What kind of service should we use? The services is basically the way that the containers communicate between each other. Because they don't communicate directly, they use a Kubernetes service. Ingress configuration, we had lots of problems with that part, including there was an upgrade on Ingress Nginx that made our website broken because there was a regex expression that they didn't like. So yeah. Health checks. Before we had just one health check. Now we have 3 types of health checks. And health checks are really important for stability. Because in Kubernetes you have the startup one, readiness, and the liveness, which is a very good idea. Liveness is like the old one, the one that recreates the container if it's a problem, and readiness is for the load balancing part. Simplicity and consistency in naming, because I don't know, Kubernetes is complicated, and if you put simple names, it helps people a lot. Stateless versus stateful. What are you going to choose? Depends on application, I guess. And the Bitnami. It's good, like Bitnami are, I guess, were the most popular Helm chart repository. And they have good things that they have bad things that they do. Should we use them an example? Should we use them as a counterexample? Yeah, we'll see. So the choices that we made for us, we chose to do one namespace to one application and 3 components for each namespace. One database app, one backend, one frontend. We decided to set the app version of the application of the Helm chart to be the Docker image version of the main, basically, application. So, for example, for backend, it's the Plone version. Because Helm charts do not allow anything that is not the semantic version, the major minor patch. So if you had some kind of image with anything else, alpha, beta, you can't put it in the version of the Helm chart. External services to manage communication between applications. In case you want to move the database to another location or just connect to a different database, you don't need to do any change. And the possibility to adjust service types in order to enable debugging, because you have the load balancing that is in front of it, ingress, then you can have an nginx if you have some kind of different configurations, then you have varnish, and then you have the Plone container or the front-end container. So sometimes if there is a problem, you don't know where it is. So you have to be able to find the location where it's broken. Basically, this is like a rough sketch of the structure of our Helm charts. The italic ones are like the ones that you can enable if you want. For example, for debug, the developers are using for front end, it's the same container image as the front end, but with the volume that mounts the sources of the add-ons, because we work on a lot of add-ons. So basically, this is how we are using. The same is the debug for the backend, the Python X, the Python plugins that have the development version on them. Okay, so now I'm going to show you Rancher v2. Basically, this is the main features that we found that are the best of like the things that we love about it. And I will actually show you the development Rancher from EEA. First thing that you know, should I make it a little bit bigger maybe? Okay, so projects. Projects allow the possibility to group namespaces in one like Rancher specific grouping that gives rights to it. So for example, here we can see who are the people that have access to this application, Plone websites, and then we can add someone else. Permissions can be done custom. Here, you can even give who needs to do what. Okay, this is, we have all the metrics is integrated here, so you can see per node this kind of information from Prometheus. You can see this, this is per node, but you can also see per container, this kind of information. Everything here is grouped by the type. So yes, what we are the most interested in is, of course, the apps. Because our release managers are not Kubernetes experts. Basically, here is how they do an upgrade. They just come here, click, and everything is configurable in this kind of information. This is very good because you can also put documentation here. Basically, this allows you to put this kind of data. This is the grouping that you can put so it's easier to read. And the most important part, you can even hide variables that are not used. So this is conditional. What happens, these variables are basically these values from the values YAML file. So this is kind of a hidden site for release managers to modify a very big file, and it's easy. So here the upgrade is very easy. You just press upgrade and that's all, and you wait. It also allows you the possibility to downgrade. Just select another version and put the old version back. Okay, so this is like a small demo. You can see basically it even gives you the command that is running. This is the command. This is, we are waiting for it to finish. It will say successful after the health checks are okay. Here you can also see the workloads. I can put here advisory board, so I can see only advisory board namespace information. And as you can see, I can put age and see what's happening here. Anyway, moving on here, our presentation. One second. So yes, metrics I've shown you, UI very easy, Helm app deployment and upgrades, yes. Component level upgrades, yes. Sometimes developers don't want to upgrade all the Helm chart, they're testing something else, so they just go here to deployments, choose this for example, edit configuration, go to the version of the here, and put something else. For example, this is basically the same, but you see the idea. So it even allows you to update the small thing from the UI without needing any extra knowledge. And it's pretty easy to see what's happening here. It's visual. Green looks okay. If you click here, you can see the old one and the new one. Okay. Now we're moving to this is basically the same thing that I showed you. I put it in case there is a problem with the internet. Our Helm charts. So, slideshow. Huh? Yes. So this is the URL of the EEA Helm charts. It's hosted via the GitHub pages. It's not the best solution, but it's not, it's workable. I think we will move it in the future because it's already getting too much. Because we're still in deploying development on the Helm charts, we have a lot of changes and it's very difficult to track commits because there are no tags. So you have to check. It's very difficult to find what exactly was changed between two versions of a Helm chart. You have to really, even if you compare the dates, the commits of this one and that one, because at the same time there's a lot of deployment on other Helm charts, it's very hard to follow what happened. So that's why we decided to do like some scripts. Scripts that are both used by Jenkins and developers that are working on Helm charts. The idea is like that. It's doing automated versioning. So we are doing minor version bump for up version update. So for example, for front-end Docker image upgrade, we will create a Helm chart minor version release. And for a patch version for anything else. For example, if you are updating the varnish, if you are updating, everything is done, of course, automatically. Or even if you're doing a change in configuration on the Helm chart, we will consider it a patch. So to be able to have a change log that's a little bit easier to follow, because there are lots of commits that are being done, mostly on the docs part for the Docker, for the GitHub pages, we decided to do 2 commits in one release. One commit is just to be able to have a change log with like a pre-commit, if you think about it, but it's basically a first commit that does only the changes that were done on the source files of the Helm chart. And the second one does everything else. Basically, the README modification with the first commit, with the changelog message, with the author and the date. The versioning increase, the index YAML, like the release of the actual Helm repository. And this script also supports recursive upstream Helm chart upgrades. So for example, we have a postfix subchart that we're using mostly everywhere. So if you do a new image of postfix, it will trigger a Helm chart release on postfix and a Helm chart release on all the other Helm charts that are using it. So a patch one, because it's not a minor one, it's a patch one. Let me show you, this is for the EEA website. So for example, EEA website backend, yes. This is how the Helm chart looks like. Let me give it a little bit bigger. And the most important part is here in the README. Releases, yes. Because Helm chart, when you do an upgrade, it just shows you this version. And to be able to see exactly what you're upgrading, you have to see the changes. So this, for example, is a automated release made by Jenkins. Basically, here, if you click on this, it will give you exactly what was changed. Yes, as you see, the application version was updated. Basically, the Docker image was updated. If you go back and see, this is, for example, is the same script. Alin did an upgrade. If you click here, you can see what he did. He deleted this part of Nginx configuration. Yes. So this basically is just for the developers to be able to see, because when you do an upgrade here in installed apps here, okay, when you do edit upgrade, as you see, we have a successful message of the upgrade. There is only the version of the Helm chart. So to be here, view chart info, you can see exactly what's happening. So yes, this is even here you can click to see what was changed if you have some questions. Okay, so this is, and the second upgrade, the second commit that is done is this one. As I was saying, we are doing, this is the package of the chart, of the Helm chart. This is the difference of the index YAML file, which is the new release with the timestamp. Because this is done with merge. If you don't do it with merge, it will recreate everything with the date of today, and you won't be able to see exactly the date that was the correct date, basically, of the release in Helm. And here is the chart update with the version. Here is the README update that we are added. So this is like a short presentation of how much time do we have? Very good. So this is like the short version of what we did without going into too many details. Whoa. Yeah, what's happening here? No idea. Let me show you the fleet. Like this is the continuous delivery solution that we did. It's not yet implemented. It's almost implemented. Rancher fleet is, I have no idea what happened here. Yeah, it's like Argo CD. I guess it's a way to be able to automatically deploy on multiple clusters, but this is the pool version. Basically, Rancher checks it if any modification was done in the fleet file, and it sees any modification, it redeploys to the configured clusters. The fleet file has this information, the namespace, the Helm chart configuration, that namespace, Helm chart, Helm repository, Helm name, Helm version, and the most important part, all the values that, all the secrets, everything else is saved in a config map. So basically, to be able to add an application, you first install it on in the namespace, configure it, see everything works perfectly. Then you save the values file with all the secrets that you need into a config map. Then you give the config map name to the fleet configuration. And Jenkins will work basically after the Helm chart is released and published. You just need to update the version of the Helm chart, and everything will start running, the deployment on pre-production. We are not using fleet on production, only on pre-production. Okay, so this was, I finished a little bit faster. Do you have any questions?
Wait a moment, we'll bring the mic to you to get it on the recordings.
What's happened here? Ah, okay. Yes.
So this is all available on the EEA website. I've worked with some of these things before, Rancher Fleet not so much. Is this something that we can take inspiration from your GitHub repositories and then work our own system on this? That's the first question. Second question is, at what scale does this setup start making sense?
You mean
deployments, development team size, that type of thing?
I guess it depends on you. I can put it just on one. It's just a script that is running. And you're just, I can show you the scripts. They're in the Helm chart root. Because I wanted to be able to use for the developers to be easier. So these are here. You have the scripts that are made. This is increased version is the main part. We are using the release script. So this one you're running and it does everything. The increase of the version, the README, it just asks you what is the commit message. So it checks if you have any changes on the source. You have to be in the Helm chart source. And it asks you, checks if there are any changes, asks you the commit message. And then it starts to putting once in the README and then does everything, version increase and even publish. After publish, it waits, checks, because we're waiting for GitHub page actions to finish. It checks when it's published, and then it does the dependent charts. Basically, checks if there are any charts that depend on your Helm chart, and then does the same process on them also. So I guess it's just a script. You can copy it. It will work. I even made it with read with options. So it asks you, are you sure? So if you run it in the wrong directory, it just says, don't run it there. Nothing to modify. You forgot to do the change. And then it asks you, Helm upgrade message parameter, you have to give it. Something like that. So basically, it's a user-friendly script because this is a big change for a lot of developers. And we wanted to give them something easy to use. And this is my preference. I usually do expect an enter after everything, so people can change exactly see exactly in the code what was changed. So, and this is the manual version, basically. When Jenkins is running, of course, it's not doing anything, README and stuff like that. So it just does the changes.
Thank you very, very much.
Yeah, okay, so this is the Helm charts. You can use them, everything is open source. Yeah, so this, you don't need Jenkins for this. You just have to be a developer and you just run the script and that's all. And the problem became when there was someone did a change on the postfix chart. And then it was a breaking change. And I wanted to see what did he change. And it was impossible, basically, for me. Because there were so many commits being made, both on docs, both on other Helm charts. This kind of mess, basically. And there is no tagging in Helm charts. It's only the main version. And so you have to have a way to follow some, and that's why we encourage, like not encourage, we make all the developers to use it. Because once one person doesn't use it, then no more changelog. But the future is no more changes on Helm charts, only automated deployment, of course. Yeah, this is, like once we have this ability, it will be only Jenkins changes.
Hi. Hi, hello, here.
Hi.
Congratulations for what you are building here. I think it's pretty awesome. My question is more regarded to the nodes on Rancher. So how do you manage the downtime when you upgrade the Kubernetes version, for instance? Because I've seen here a lot of Helm, things going on, but what about the nodes? What about preemptive nodes or static nodes? I mean, how do you manage all your deployment releases on the nodes? How do you manage to upgrade the Kubernetes version and this downtime that you may have? This Rancher offers you a good option for that?
I think so, yes, but we are not in charge of the Rancher administration. There is a different company that does this. We are only on the application side. So we are not system administrator there. So I have no way to say to you, because we have no experience in this part.
Okay.
They separated really the roles between system administrators and us, so we don't have too many rights in Rancher.
Okay, so you don't know what's going on, right? So you just deploy and whatever node it goes.
So all our applications are running now. Almost all. Because Rancher 1 is obsolete, it's deprecated. We moved 90% from there. And everything else is in the process of moving. And it works well. Of course, we had some issues in the beginning with some problems, but it's stable, it works. And they do upgrades all the time, so something is done. But unfortunately, it's not me that's doing that.
Okay. Thank you.
I can give you like the perspective of a user, of a DevOps user, and release managers, because I asked the colleagues that are release managers how easy for them is to use Rancher.
No, it's fine. It just because it's for my concern, So because if the node is down, it doesn't matter if whatever you have here, because your application is going to be down. So I think it's important, right? But if there is another team taking care of that.
Yes.
I was just curious about that. Thank you.
Thank you, Valentina. Let's give an applause for Valentina.
Thank you.